Chemistry is the study of the structure and composition of materials and how this structure and composition can change. Working in any type of process plant, you need to have an understanding of the principles of chemistry because, as you know, most processes involve change. Let's begin our discussion of the composition of matter by defining a few terms. We'll begin with material and matter. Basically, the terms material and matter are interchangeable. Material or matter is generally thought of as anything that has mass and occupies space. Mass is basically weight. So for all practical purposes, matter can be defined as anything that has weight and occupies space. For instance, this table is matter. Now, one of the simplest types of matter is an element. An element is a substance composed of atoms that are all the same. For example, this piece of iron is an element. An atom is the smallest part of an element that still has the properties of the element. Although we can't actually see atoms, we do know some things about them. This is a model of a single atom. Even though an atom is the smallest part of an element, atoms can actually be broken down further into particles called protons, neutrons, and electrons. A proton is a positively charged particle. Protons are found in the nucleus or center of an atom. Neutrons are neutral. They don't have a charge. An electron is a negatively charged particle. Electrons orbit the nucleus of an atom. An atom has the same number of electrons as it has protons. For example, this atom has 4 protons and 4 electrons. Because the positive and negative charges balance each other, the atom is electrically neutral. Elements are categorized by the number of protons in their atoms. This number is called the element's atomic number. Information about elements can be found in a periodic table, like this one. In an atom, electrons orbit around the nucleus. They do this at different levels. These levels are often referred to as shells. The electrons in the outermost shell are called valence electrons. Valence electrons are important in chemistry because they affect every chemical reaction that occurs. Basically, a chemical reaction is an interaction between the atoms of substances. In chemical reactions, valence electrons are either transferred from one atom to another or shared between 2 or more atoms. By transferring or sharing valence electrons, atoms of certain elements combine or bond with each other to form molecules. The atoms of some elements combine easily with other atoms, while the atoms of other elements don't combine at all. How easily an atom combines depends on the number of valence electrons that it has. When atoms combine, they often transfer or share valence electrons so that each atom ends up with 8 electrons in its outermost shell. A smaller atom may end up with 2 atoms in its outermost shell. Let's look at an example. Here's a simplified illustration of a lithium atom and a fluorine atom. The lithium atom has 1 valence electron, and the fluorine atom has 7 valence electrons. When the lithium atom and the fluorine atom combine, the lithium atom gives up its valence electron to the fluorine atom. After the electron transfer, the lithium atom has 2 electrons in what is now its outermost shell. When the fluorine atom gains an electron, it has a total of 8 electrons in its outermost shell. Because the atoms no longer have equal numbers of protons and electrons, they're no longer electrically neutral. The lithium has a positive charge because it has 1 more proton than it has electrons. And the fluorine, with its added electron, has a negative charge. And because the lithium and the fluorine are oppositely charged, they are attracted to each other. This attraction causes them to form a molecule of lithium fluoride. The properties of lithium fluoride are different from the properties of either lithium or fluorine. Atoms that have gained or lost electrons are no longer called atoms. They're called ions. An ion is simply an electrically charged atom. The bond that holds ions together is called an ionic bond. However, ionic bonds are not the only means of forming molecules. Molecules can also be formed when atoms share electrons. This type of bond is called a covalent bond. For example, water molecules are held together by covalent bonds. A water molecule consists of two hydrogen atoms and one oxygen atom. Each hydrogen atom has one valence electron, so that makes a total of two. The oxygen atom has 6 valence electrons. When hydrogen and oxygen combine to form water, the 3 atoms join together by sharing the 8 valence electrons. The 8 electrons orbit around all 3 nuclei, and it's the sharing of these valence electrons that holds the water molecule together. So, to summarize, we looked at 2 ways that atoms can bond: by transferring electrons, that is, an ionic bond, or by sharing electrons, a covalent bond. I'll stop now so you can check your understanding of chemical bonds. In this topic, we looked at an introduction to chemistry. We covered the structure of an atom, definitions of key terms, and how valence electrons are involved in chemical bonding. Now try some practice questions to check your understanding. Neutrons are neutral. They don't have a charge. An electron is a negatively charged particle. Electrons orbit the nucleus of an atom. An atom has the same number of electrons as it has protons. Atoms that have gained or lost electrons are no longer called atoms. They're called ions. An ion is simply an electrically charged atom. The bond that holds ions together is called an ionic bond. However, ionic bonds are not the only means of forming molecules. Molecules can also be formed when atoms share electrons. This type of bond is called a covalent bond. For example, water molecules are held together by covalent bonds. A water molecule consists of 2 hydrogen atoms and 1 oxygen atom. Each hydrogen atom has 1 valence electron, so that makes a total of 2. The oxygen atom has 6 valence electrons. When hydrogen and oxygen combine to form water, the 3 atoms join together by sharing the 8 valence electrons. The 8 electrons orbit around all 3 nuclei, and it's the sharing of these valence electrons that holds the water molecule together. A compound is a product of a chemical reaction. It's formed when 2 or more elements are combined or bonded chemically. A chemical reaction is a reaction that forms a chemical bond, breaks a chemical bond, or simultaneously forms and breaks chemical bonds. Let's look at a chemical reaction to understand compounds better. We'll start with the element copper in the form of these 2 copper wires, and the compound sulfuric acid. These materials can also be called reactants because they will react together. Because this reaction occurs slowly, I'll speed it up by adding electrical energy. This is done by connecting the copper wires to a battery. Sulfuric acid is a colorless liquid that contains hydrogen ions and sulfate ions. A sulfate ion consists of 1 sulfur atom and 4 oxygen atoms. Adding copper to sulfuric acid results in a chemical reaction that forms copper sulfate and causes hydrogen to be released as a gas that bubbles out of the liquid. Over a period of time, the liquid turns blue, indicating the formation of the compound copper sulfate. This reaction will continue only as long as both copper and sulfuric acid are available. We can tell the reaction has stopped when hydrogen gas is no longer being released. At this point, if we add more copper to the beaker, we will not produce more copper sulfate because there is no more sulfuric acid for the copper to react with. Now, one of the things we learned from this demonstration is that the characteristics of reactants can change dramatically when compounds are formed. In fact, the properties of compounds are different from the properties of the elements that combine to make them. Another fact about compounds is that their proportions are fixed. Each molecule of a compound consists of specific numbers of specific atoms. For example, a copper sulfate molecule consists of 1 copper atom, 1 sulfur atom, and 4 oxygen atoms. Now that you have a basic understanding of compounds, I'll stop so you can try an activity. A mixture consists of 2 or more materials that are not joined together chemically. Unlike a compound, which consists of 2 or more elements that have combined or bonded chemically, when a mixture is formed, the properties of the materials that produce the mixture do not change. Another difference between mixtures and compounds is that the proportions of the materials in a mixture can vary. I'll show you what I mean with a little demonstration. I'm going to make a mixture of sand and iron filings. To prepare it, I simply put the sand and the filings together and stir. I can add more filings or more sand to this mixture, and it's still a mixture. When materials don't react chemically, it doesn't matter how much of any material you have. Another way in which mixtures differ from compounds is in how they're separated or broken down. Compounds are formed and separated only by chemical reactions. Mixtures, which are formed mechanically, such as by stirring, can be separated mechanically. For instance, a magnet can be used to separate iron filings from sand. So what we've seen is that a mixture is simply a mechanical blend of two or more substances in any proportions. The materials are not combined chemically, and they can be separated without a chemical reaction. In this topic, we looked at some demonstrations of how compounds and mixtures are formed. We saw that a compound is formed by a chemical reaction, and a mixture is formed mechanically without a chemical reaction. Now, here are some practice questions for you to check your understanding of compounds and mixtures. A compound is a product of a chemical reaction. It's formed when two or more elements are combined or bonded chemically. A mixture consists of two or more materials that are not joined together chemically. Unlike a compound, which consists of two or more elements that have combined or bonded chemically, when a mixture is formed, the properties of the materials that produce the mixture do not change. A solution is a special type of mixture called a homogeneous mixture. The term homogeneous refers to the fact that the materials in a solution are evenly mixed. A solution can be a mixture of solids, liquids, or gases, or a combination of any of these, as long as the materials involved are evenly mixed. One example of a solid solution is an alloy, which is basically a solution of metals. This piece of yellow brass, for instance, is a solution of 67% copper and 33% zinc. Air is another example of a solution. Air is a solution of gases. It's approximately 78% nitrogen and 21% oxygen. The other 1% consists of carbon dioxide and elements such as helium and neon. What makes air or any other mixture a solution is that whatever is in it is evenly dispersed throughout. There are two terms associated with solutions that help describe what they're made of: solute and solvent. The solute is the material in a solution that's dissolved. The solvent is the material that the solute is dissolved in. For example, we're going to make a solution of dye and water. The dye is the solute. The water, in this case, will be the solvent. Let's assume this beaker contains 1,000 grams of water. I'll add 10 grams of dye and stir. The solute, which is the dye, is dispersed evenly throughout the solvent, the water, so we have a solution. Now, if I add more dye, the solute is still evenly dispersed throughout the solvent. But there is a difference. The solution is darker. That's because the solution is now more concentrated. The term concentration refers to the amount of solute present in the solution. The greater the amount of solute, the more concentrated the solution. Solutions are often described in terms of their concentration. A common expression of concentration is percent by weight. The term percent by weight refers to the concentration of solute in a solution expressed as a percentage of the weight of the solution. Basically, in a percent by weight solution, the percentage is based on the weight of the solute in relation to the weight of the solution as a whole. For example, the solution in this container weighs 1,000 grams. It consists of 10 grams of solute, which is dye, and 990 grams of solvent, which is water. Since this solution consists of 10 grams of solute in 1,000 grams of solution, it's a 1% by weight solution. With 200 grams of dye and 800 grams of water, this is a 20% by weight solution. The percentage for a percent by weight solution is always based on the solute's weight relative to the weight of the whole solution. Using percent by weight measurements helps us to see how solutions with different concentrations relate to each other. For example, the 20% by weight solution is 20 times as concentrated as the 1% by weight solution. Now, figuring out the weights of the materials in a percent by weight solution is simple if you know the percentage of solute and the weight of the solution. For example, if this drum contains 200 pounds of a 5% by weight salt solution, we can calculate how much solute, which is the salt, and how much solvent the drum contains. The first step is to multiply the weight of the solution by the percent of solute. 200 pounds times 5% equals 10 pounds. So there are 10 pounds of salt in the drum. Now we can use subtraction to find the weight of the solvent. The weight of the solution, 200 pounds, minus the weight of the salt, 10 pounds, equals 190 pounds of solvent. Some solutions are characterized by their pH measurements. A solution's pH is a measure of the relative acidity or alkalinity of the solution. The terms acidity and alkalinity refer to the relative amounts of hydrogen ions and hydroxyl ions dissolved in a liquid. A hydrogen ion is a positively charged hydrogen particle. A hydroxyl ion is a negatively charged particle made up of hydrogen and oxygen. A pH scale, like this one, is typically used to measure a solution's pH. When the relative amounts of hydrogen ions and hydroxyl ions in a solution are equal, the solution is neutral. A neutral solution has a pH of 7. From 7, the numbers on a pH scale go up to indicate increasing degrees of alkalinity and down to indicate increasing degrees of acidity. Between each two whole numbers on the pH scale, in either direction, the concentration of the solution changes by a factor of 10. For example, from 6 to 5, the acidity increases by a factor of 10, and from 5 to 4, the acidity increases 10 times more. So, a solution with a pH of 4 is 100 times more concentrated than a solution with a pH of 6. The same progression holds true for alkaline solutions. A solution with a pH of 9, for example, is 10 times more concentrated than a solution with a pH of 8. Well, in this topic, we looked at solutions. We saw what a solution is, and we saw how two solution characteristics, percent by weight and pH, can be measured. Now try a few practice questions about the information we've covered. A solution is a special type of mixture called a homogeneous mixture. The term homogeneous refers to the fact that the materials in a solution are evenly mixed. A solution can be a mixture of solids, liquids, or gases, or a combination of any of these, as long as the materials involved are evenly mixed. Now, figuring out the weights of the materials in a percent by weight solution is simple if you know the percentage of solute and the weight of the solution. For example, if this drum contains 200 pounds of a 5% by weight salt solution, we can calculate how much solute, which is the salt, and how much solvent the drum contains. The first step is to multiply the weight of the solution by the percent of solute. 200 pounds times 5% equals 10 pounds. So there are 10 pounds of salt in the drum. Now we can use subtraction to find the weight of the solvent. The weight of the solution, 200 pounds, minus the weight of the salt, 10 pounds, equals 190 pounds of solvent. Between each two whole numbers on the pH scale, in either direction, the concentration of the solution changes by a factor of 10. For example, from 6 to 5, the acidity increases by a factor of 10, and from 5 to 4, the acidity increases 10 times more. So, a solution with a pH of 4 is 100 times more concentrated than a solution with a pH of 6. The same progression holds true for alkaline solutions. A solution with a pH of 9, for example, is 10 times more concentrated than a solution with a pH of 8. This reaction will continue only as long as both copper and sulfuric acid are available. We can tell the reaction has stopped when hydrogen gas is no longer being released. At this point, if we add more copper to the beaker, we will not produce more copper sulfate because there is no more sulfuric acid for the copper to react with. Now, one of the things we learned from this demonstration is that the characteristics of reactants can change dramatically when compounds are formed. In fact, the properties of compounds are different from the properties of the elements that combine to make them. Another fact about compounds is that their proportions are fixed. Each molecule of a compound consists of specific numbers of specific atoms. For example, a copper sulfate molecule consists of 1 copper atom, 1 sulfur atom, and 4 oxygen atoms.